Hello everyone. Welcome back to the day 6 of our Machine Learning and TensorFlow Bootcamp organized by GDSC SNU in collaboration with Skepsis. Excited for the hands-on workshop based on your ML project today? You may flood the inbox with all your hypes. Without much ado, I would hand on the baton to Archisman Ray, who is the mentor for the day. Thank you.
Thank you, Ankana, for the lovely introduction. So today we are gonna do about the computer vision project. So what is the project? How many of you guys have done the watercolor? Like when you were small, you guys did not the watercolor, but painted your picture with watercolor. So we'll be doing that. Okay, Sunray knows. Okay, so we'll be doing that only. Also, in the first session of the computer vision, Jabrata sir mentioned about filtering, sharpening. Okay, so we'll be using those filters, those blurring techniques, those filtering techniques, and those sharpening techniques to implement in our project such that we can get a blurred image. Okay, so let's get into it. Just give me a second. Okay, so we have divided the things into four parts. One, two, three, four. First part is we'll be taking the input of the image and resize it. Second, we'll be clearing the impurities. What by impurities I mean is we'll be clearing the variations, the color variation, the noise reduction, the various part by using the blur. Then we'll be apply filtering methods. By using filtering, we will be like doing it more into the watercolor state, and after that we'll be tuning the image, tuning the art, like we're sharpening or dehazing or color enhancement. These are the various techniques of tuning the art. Okay, so now we'll be what we'll be using. Let's see it. Okay, so I will be making the project with you guys. So let's get started. Okay. So for the input image, what's the libraries to import? Import CV2, import NumPy, as NP, and from total.collab patches import CV2 and show. Okay. Oh, I forgot to connect this thing. My bad. So it will take some time to connect and then compile the following cell. So let's get ahead with the rest part. So then we'll be starting to read the image, where you will give the image path. Image path you will give over here. Okay. And after that, so for image path, I am using this particular image. You guys can use any image, whatever you want. So I found this image to be like better suited as an example. So I used it. So let's see what's the image. Okay, CV2, I'm sure. So this is the image, as you can see. Okay, a very noisy image. Okay, so we'll be using this image and we'll be changing it into a search image such that it can be like it looks like a watercolor image. Okay, like it would look like you have like you drew the image. Okay, so yeah, let's get into it. Now obviously for this particular size we can work with this size. Now if you import certain image which you have, it can be a greater size than this. So obviously we need to resize it now, because if we don't resize it, then the blurring filter won't like do properly or won't act properly. Okay, so we'll be resizing it first. So what will be the code? Image resize equal to cv2 dot resize image. We'll be sending the image as a parameter, and done. And we will be okay. Let me just complete the sentence and I'm saying it. Fy is equal to 0.5. Now over here, what this 0.5 means, it is multiplying the image size into 0.5. What does that mean? If the image size is 1, it will be multiplying into 0.5, which will reduce the image size to its half. Okay, so this is basically reducing the image size to its half of length. Okay, so if you see the image, CV, am show I am show image resized. You see, the image has been resized. Okay. Now, moving on to the second part is the clearing of the image, like clearing the impurities. Okay. So we will be using median blur. Median blur was discussed by Debrata sir. So I won't go through that again. So I will just show you the syntax, how to apply a median blur. cv2.median blur, and we'll be sending the resized image with the kernels as a 3 into 3 matrix. Okay. So if you see, we will get a blur image. So image. As you can see, we have a blurred image. Okay, a bit of blurred image, but for working with this thing, like for converting into a watercolor art, we need to blur it more. Okay, so that we can convert it into like watercolor art. So we will be using this median blur for approximately 3 times. Okay, so that we get a good filter image. So we'll be using this thing again. Control C and Control V. So now you can see the blurred image. It has been blurred. Okay, you can't identify it properly. So we'll be using. Okay, let's use edge filtering, edge preserving filter. What it does, it blurs the image, but it preserves the edges. Okay, it does preserve the edge. So as you can see, this was the image. It was so noisy, and after using blur, the noise has been reduced. So median blur is basically used to reduce the noise in the particular image. Okay, so that's the thing. First thing. The second part is we will be using, like, to make it more better, we will be using what do I say, edge preserving filter. Okay, so image clear is equal to cv2 dot edge preserving filter. I will be passing the clear image, like the upright now, till now what filters or what blur we have done, the medium blur we have done, we are passing that particular image into it with a sigma value of 5.
Otishmanda,
Yeah, sure. Hello.
yeah, after you complete this part, can you just show us the code from the first once again?
Which one? Which one? Which one?
Like complete beginning.
Complete beginning.
Yeah,
This one?
yes, thank you.
Okay. Oh, I can't see the chat now. Wait a minute.
Yeah, you can scroll down now.
Okay, okay, okay. Okay, I was too fast, I guess. My bad. Didn't see the chat. Okay. Are you done with this now? Till this? Chandri?
Yep, writing the codes. I've taken screenshots, so you can just
Okay, okay.
go.
Okay.
Yeah.
Okay, just try to be with me. If I am going too fast, no issues. People can ping me up and say, okay, we are a bit slow. So it's fine, okay, completely. So just get it done till now, because if you do simultaneously, it will be better experience. Okay. Okay. So till here, I have given the edge preserving filter. What edge preserving filter does, it basically preserves your edges as it states by the name, and like it applies the blurred method. So if you compile it and see it, give me a sec. Oh my bad. I should look. Yep. So as you can see, from the previous image to this image. So you can see the blurring, the blood. Oh yeah, I just messed up a bit. Okay, so over here we have applied the medium blur, and after applying the edge filtering, okay, after applying the edge preserving filter, we can see the change in the blurred image. As you can see over here, the blur has been applied perfectly by preserving the edges. As you can see, the edges have been preserved over here. Okay. Now the common question that can arise in your mind is what is sigma? So for now, what you can understand, sigma is basically it's an extent till which the color will be mixed. Okay. So the more the sigma value you have, like it will make like it will mix the color more. So I have kept the sigma value less. So as you can see, this particular like this particular pumpkin has many color, but this has changed into one particular color, like almost a color. Over here, then it has changed almost a particular color. Okay, is this evident to you guys? You can see almost it is of like one particular color. Over here, you can see it like it has changed into one particular color. Okay, am I clear till this much? Shade's gone. Yeah, yeah. Cool, cool, cool. Okay, nice. So after this, we'll be doing. Okay, give me a sec. Yeah. So after this, what we are going to do right now is we have like clear the impurities. Now what we'll do, we'll apply like bilateral image filtering. The filtering part will be going in. Okay. So if you guys have cashed up till bit, just say a hi or +1. Okay. If you are with me, just say 1. Just write down 1. Till this thing. Okay. Has anyone completed it? Let's see. Writing. Cool, cool, cool. Take your time. Take your time. Take your time. No issues. We'll go a bit slow then. You can actually. Well, if you put in that way, mm, you can. Sigma color is basically till how much extent like it will mix the colors. So yeah, you can actually. Let me just check one thing out. Okay, so done, Aratrika done, rest. Yeah, Aditya, you were right, okay? I just checked with one documentation, so I did take a bit time. So sorry. Anyways, so moving on with the next part. It is about filtering the image. Okay. So just give me a sec. Let me write down the code first. Okay. Till this much, if you have written the code, just say hi. Okay. Okay. So like you guys write it down the code, no issues, take your time. So till then I'm just explaining what is bilateral image filtering. So if in layman terms if you want to understand, it is just giving the blur and preserving the edge. Okay, so that's what it is, bilateral filtering. Now image filtered, what we are doing is we are passing the image and we're passing three values: the diameter, the sigma color, and I guess this is the sigma size, or yeah, this was the sigma size. Okay, so over here, what we are saying, there is a sigma color. So sigma color is again at which extent we are mixing the color. Okay. So as I guess Aditya mentioned, it was a color smoothing technique. So the higher the color, like the higher the sigma color, the larger values will mean like more pixel will be blended together. Okay, creating a smoother color transition. A smaller value means fewer pixel will be blended together, creating a sharper color contrast. Okay. So that's it. So over here we are using the bilateral filtering. So as we need to do it in like watercolor, the watercolor art needs to be performed better. So we'll be using this bilateral filtering multiple times. Okay. Okay guys, also if you guys don't understand any part, do ping me up. I'm just a bit not well today. So there might be a bit miscommunication between us. So feel free to, you're not understanding some part, okay? Anyways, so we'll be applying this part again. We'll be using a loop for our range of 2. I will just like increasing the smoothing this. Okay. So over here we are passing the filtered image. So we are passing this particular image bilateral. This particular image we are passing it again to get a better image, to get a better blurred edge preserved image. Okay, so we'll be passing it 3 times again, and give me a sec. Filtered, comma 5, comma, let's get 30, and over here 10. Again, it's up to you guys. You can play around it with these values and you can see how the image is being changed. Okay. Okay, 3, 10, and 5. 3 represents the diameter at which the color is getting mixed. For example, if this is your image, so at which diameter, like how much of area it will getting mixed. Okay, how much of area it will be attracting the colors, and like it will, what is image? Image is matrices. Okay, so for example, if you have a 16 by 16 matrix, now if you give the diameter of 3, so it will break down that into 3 into 3, means first it will take the upper quadrant, it will be trying to mix those particular colors. So what I mean by mixing of colors, it is taking the values from each of the pixels, trying to coordinate it or trying to make it in a similar pattern. As you can see, there is a huge difference between this particular pixel and this particular pixel. Okay, so the values are changed drastically. Okay, but over here we are managing, we are trying to. Okay. Am I clear? Okay, so Nimesh was asking about bilateral filtering. So bilateral filtering is basically a technique that blurs the image while preserving the edges, as I said before. So it uses two particular parameters: sigma color, which controls how much filter, like how much the filter considers two pixels to be similar in color. Okay, as I said right now. and sigma space, which controls how much the filter considers two pixel to be close, okay, to be close in space. Like it will say you how much like pixels are in the close space, close proximity. Okay, is it clear? I'm quite not sure I could like made you understand this part or not. Okay, if you guys have any doubts, still you can just say. There's no issue. Okay, let me think about how can I explain you bilateral filter in a bit. Okay, let's imagine you have a painting and you want to make it look more artistic by blending the colors and creating brush strokes. Now you can do this by using a soft brush and applying some paint over the original painting. Okay. However, you don't want to cover the edges that defines the shape and object in the painting. You want to keep them sharp and clear. So you use a brush that is sensitive to color and distance of the pixel in the painting. If two pixels are similar in color and close in distance, okay. If the two pixels, for example, these are the two pixels which are same in color and close to the pixel, what we do, you blend them together. Like over here, wait a minute. These this pixel and this pixel are almost similar. Like these two colors are almost similar. So try to blend in. When you blend in, you see you get this type of an image. Okay. Now, if two pixels are different in color or far in distance, you leave them alone. Like you don't touch them. For example, this pixel and this pixel, this particular pixel and this particular pixel are like different in color proximity. Okay. So you just don't touch them. Like you don't matter with them. Okay. So that's the thing. Okay. It was a bit clear with you guys. The bilateral filtering part. Cool. Okay. So moving on ahead with the image cleared. So we apply the bilateral filtering and we get this particular result. Okay. Like it is now you can see like it is somewhat converting it into a like watercolor shape. Like isn't it looking like a watercolor sort of thing? It's not right now a totally a watercolor stuff, but it will like होगा ना धीरे धीरे दिखेगा वो चीज ठीक है. So right now we are just filter the image. Now we'll be tuning the art. Okay, we'll be tuning this particular image. Now, what is tuning this image? What I mean by tuning? Tuning, I said sharpening, dehazing, color enhancement. Now, in sharpening, in Debrata sir said about something about sharpening. Do you guys remember about anything about sharpening or color enhancement? Anything? Anything, guys? Look, come on. Increasing contrast, okay. Somewhat, yeah, okay. Others. Siddhant said, others. So sharpening is basically a process of enhancing the edges and fine details in an image to make it appear sharper and more defined. Okay, you guys have edited your pictures now, so there was an option to sharpen in your image. So the sharp means होता है ना कि आँखों में चुभता है वो चीज़. So it was that particular phrase कि when you sharp the image more, तो वो चीज़ आँखों में चुभता है. So that is the sharpening of your image. Okay. So it is important. Why? Because it can help out to bring out the details and feature in an image, making it more visually appealing and easier to understand. Now, color enhancement is another process of improving the colorfulness and contrast of an image, as Adnan said, to make it more vivid and realistic. So we will be doing this particular things right now so that we can fine tune this image and make it more of watercolor stuff. Okay, so it will be a quite short session, I know, but yeah, let's dive into it. First, using sharpening the image using add weighted. After I write this particular thing, I will be explaining you what is happening. Okay, you guys know about the like Gaussian filtering, like the Gaussian blur. It was said. Someone remember, no? Someone they joined about that session. So let's hear from you guys. What is Gaussian blur? Let's hear from you guys. Black and white present construct. 0 to 50 black and white. No, what you're saying, Aryan, is you're talking about grayscaling of an image. That's not Gaussian. Yeah, cool. Okay, Siddhant. Okay, good. Nice. Siddhant is actually quite right in this thing. Using kernel table to blur image. Nice. So you guys paid attention in that. Okay. I will explain a bit more. Give me a sec. So Gaussian blur is basically used to like create a blurred version of the image, like with a kernel size. Okay, over here we have given a kernel size of 7. Okay, and a standard deviation of 2. Now it is basically doing the blurring part for those who didn't attend that session. So you guys right now think it has a like blurred part. Like we use the medium blur. Likewise, we are using our like Gaussian blur again. Okay. So that's the thing about the kernel and all. Sir explained. Please do refer to that video and check that out because you need to see that video to understand these things. Okay. Anyways, so now we'll be sharpening the image. How will be sharpening? That's the interesting part. Focus. 1.5 comma Gaussian mask minus 0.5 comma 0. There is another thing over there. Add weighted is equal to range of 1. Okay, so what add weighted function does? Add weighted function. So what is images? Images are like matrices. It is an array. Okay. So to get a sharpened image, what we do? So we want to get a sharpened image of this particular image. Okay, which is image filter. So what to find out any sharpened image of a particular image, what we have to do? Take that image and blur that image. Okay, and subtract that image from it. Means subtract the particular image with the what I say the blurred image. Okay, so what we are doing over here, we're subtracting image filtered minus of Gaussian marks. Now how are we gonna do it? Now what add weight function does? This is alpha. This 1.5 is alpha. This minus 0.5 is beta, and this is gamma. Okay, so what add weight function is doing? It is multiplying the matrix image, this particular matrix, into 1.5 plus image 2. What does that mean? The Gaussian marks into this minus 0.5. Okay, into beta, such that this can minus itself. Okay, so what it does, that image like 1 alpha minus of image 2 alpha. Okay, with the plus of gamma. Am I clear? Others, Shauvik, Ayantika, others? Cool. So by this way we can sharp the image. If we see it, there is a problem. Please don't see my spelling error. Yeah, it was a spelling error. Nice. Okay, I got it. Next trick. For sharpening image, what sharpening means is sharpening means in image Levels of blur of that image. Right now, understand this particular part only. Okay. To get a sharp image, just get your mean image, blur that image, and subtract it from from the mean image. Okay, so you will get the sharpen image. Am I clear? Sarji, cool. So we'll be seeing, we'll be sharpening it a bit. Okay, let's see first how it is doing. CV2 and show image sharp. It's almost done, but we need to sharpen it a bit more to get it a vivid color. Let's see. Image sharp. Control C, Control V. Let's change it a bit. 1.4 or 0.2. Let's do it and make the gamma step. Let's see what happens. Yeah, it is almost converted into the watercolor image. Okay, if you see now, if you compare all the images, CV2, I am show of image clear, CV2, I am show of image resized. I can say this was the image. This what we get after the removing the impurities, and this is our final output. This is a final, what I say, the watercolor art. Can I see this watercolor art? Okay, I guess it will be more visible with my picture. Wait a minute. Wait a second. Where was this picture? Let's see, try with this image. Okay. Mm, see, if you see this image, like it has converted it into full watercolor art. You can see the things also, but the edges are being preserved because of the edge filtering technique. So that what you get from this to this. Like it is looking like full watercolor now. If you see it like that thing, isn't it looking like a watercolor stuff? Like how you have painted it and all. Okay, guys are bored, I guess. Okay, my session was too boring for today, I guess. Sorry, guys. I couldn't be there. Okay. Anyways, so that's a cool particular thing with computer vision you can do. I am not going into extent of object detection or anything because you guys know on contour detection or in object detection, it takes a bit time. Okay, so you guys knew about blurring, so taught about blurring and all. And in the previous session, I showed you like how you can detect an object. Okay, with using ultralytics model. So that's it. If you guys have any question regarding these things, or if you have any doubt regarding the project of the linear regression part, you can do too. Also, there is a thing with the linear regression. If you guys try to implement a new machine learning model by learning, I will name some machine learning model like decision tree, like random forest. These are the two easy, easy machine learning models, like algorithms which you can learn. If you go to a bit difficult level, like classification level, you can go to SVM. Okay. So you guys learn about this model if you want to and try to implement it in the dataset I have given. If you do so, that will be great and that might increase your chance of being like coming to first. Okay. So right now, if you guys have any doubt, do same. Okay. Do you guys have any doubt regarding this particular part? Also, don't worry, I'm not giving project in this computer vision part. So there are no projects in computer vision, but yeah, this is a surprise. So that's the thing. So do you guys have any doubt? Mention fast. Okay, Ankana. So we can move ahead with.
Yes. So right now we have a short assessment to test your knowledge about the previous weeks, whatever you have learned, and we'll be sharing the link with you within 5 minutes.
Best of luck, guys. আচ্ছা চন্দ্রি যদি এরর আসে আমাকে না একটু ডিএম করে দে এররটা কি এরর আসছে ডোন্ট ওয়ারি অ্যাবাউট দ্য এরর সো জাস্ট ডিএম
So the form has been opened. You can go ahead with your assessment.
so also Angana do they need to be staying in the meeting like
Yes,
are
they
you
need
tracking the
to be.
attendance
Yes, yes, they need
so
to
do
stay.
mention that in the group okay? So people have left I said
Okay. Everyone, please stay in the meeting.
Okay, it seems Anirban was the first person to join. Okay, sorry, to complete. Anirban Das. Nice. There is one trick question in the form, so do fill the thing carefully. There is a trick question. So Those are submitted. Please stay because I'm going to discuss at the end one part. Okay, but anyways, those are some. Angana, can they leave? Those have already submitted it.
Yes, they can leave. You may leave the meeting if you have submitted.
Okay. Then, yeah, guys. See you next time. Angana, I'm just leaving the meet if it is.
Okay, okay.
Okay, cool. Thank you, guys. Best of luck for the exam or for the assignment, and do submit all the projects. Okay, the projects are important for the evaluation. See ya, guys. Just leave the call.